Okay, so today we're going to talk about some interesting bits of stuff. We're going to start out with a triangle and a circle. Now these particular triangles and circles, we're going to have this be the radius. And that's the distance from the center of the circle to the outside. And with that radius, we have the center point, and then we have this triangle that's made from the axis. This is being the x-axis, and this is the y-axis. And that radius, and then we have an angle right in here. I'm going to label like that. And that angle is opposite this side over here. So this is the opposite side. And it's next to the adjacent side. And the radius, we're going to give that another name because, you know, hey, why not? That's going to be the hypotenuse. Now, there's relationships between each of these sides. On this triangle, we could draw a bunch of different triangles as long as the hypotenuse and the radius matched. We could draw another one up here, another one up here. It wouldn't really matter. The principle, the arrangement's the same. The naming scheme, if you will. Alright. So we've got adjacent has another name. This could be the run. And the opposite could also be the rise. And if we're going to give them letters, we can say an A, a B, and a C. So if we go to Pythagoras, and he has this triangle, we made an observation with squares where the 3, 4, 5 triangle, the A side squared plus the B side squared was the same as the C side squared. And so we have the Pythagorean identity, which is the A squared plus B squared is equal to C squared. And then we have the following trig identities. And there's a mnemonic to remember these, which is that's not an L, that's an A. So it's so, ka, to. So so is one word, ka is another word, and to is a third. So that stands for sine is equal to opposite over hypotenuse the cosine is equal to the adjacent over the hypotenuse, and the tangent is equal to the opposite over the adjacent, which is also equal to the rise over the run, which is equal to the slope. So these all identify the relationship between this triangle and the circle. Now I have this handout that is on the website, and available. I mean, I handed it out in the class and it's on the website. And then we have this other, which gives a more detailed view of a quarter of the circle. So it's just this part right here, and this is just a bigger view. And then I have grid lines. I have big grid lines and little grid lines. And the big grid lines are for every 10 or every 1, and then the small grid lines are for the tenths. So that allows us to make some measurements. Now, I've already filled out ones for the 3, 4, 5 triangle and its companion, which are marked through the 3 up, 4 over, line right there, big line through there, and it has another one. If we go up 4, 1, 2, 3, 4 here, over 3, we got this line right here, which is 53.1 degrees approximately. And so we've got those in there. Oh wait, opposite over adjacent is probably going to be not. Sorry, I got confused for a minute. That would be 4/3, which would be 1.333, like so. Alright, so now we're going to look at how to fill out the rest of this chart. So the hypotenuse, 1, 2, 3, 4, 5, 6. Hypotenuse is going to be 6. My hypotenuse squared, 6 times 6 is going to be 36 square inches. And for 10 degrees, my opposite, I'm going to look right here and count over 3, 4, 5, 5.9. So the adjacent, as would be the adjacent, would be a 5.9. And the opposite is how far up. So 1.1 would be here, 1.03. So that's a really rough approximation. I'm just writing in there. And then the sine, cosine, and tangent. Sine, I'm going to divide these two. Cosine, so sine is opposite over hypotenuse. Cosine is adjacent over the hypotenuse, and tangent is opposite over the adjacent. I just do the division on my calculators and fill those in. And since the opposite and adjacent are my A and B, opposite squared plus adjacent squared is going to be equal to, that should equal 36, or be really close. Now how far, our measurements are not precise enough really, so there's going to be a little error, but that's the process. And as you go through, use your calculator, fill in the values, you'll start gaining an understanding of sine, cosine, and tangent, or the trigonometry functions. R-I-G-E-T-R-Y. Hopefully I spelled that right.